inbuilt libraries as in some pre-written code, like just like how a physical library will have loads of information in the form of books written by so many knowledgeable people. Same way, some guys have created some code and made it available to us in the form of libraries. We borrow their code, we use them. So there is a built-in library called as OS, right? As the name suggests, this is the pre-written code which is wrapped inside this library is used for performing some OS level operations. So to be able to do that, first I have to do import OS. And we'll be seeing these things again when we talk about packages. So I edit and import OS. Now from OS, I want to call an inbuilt method called as system, which will help me to execute system level commands, right? Like what is my present working directory, clear screen, and so on. Why did I do that? Because I don't want to exit the Python environment and clear the screen and then come back here. So from here itself, I would like to have this feature, like, okay, being able to execute some Python commands from within, some OS level commands from within the Python environment. Okay, so that's how you take input from the user using the input function and entering some suggestive text, which will help as a help text to the user. What is he supposed to enter? Okay. Now, we had seen, we had discussed in the previous class that data comes in different types, like textual data, numerical data, mapping type of data, collections of data, right? Textual data is like your names, your descriptions, your log files, whatever text goes into log files, all that is your textual data. Numerical data is like your count of interfaces, ages, heights of persons, anything that you represent as a number, right? And then you also have Boolean kind of data. Boolean is like true, false. So there will be such certain questions where the answer will be yes or no, or true or false. Like an interface is enabled or not, or shut or no shut. Right? The answer will be yes or no. To represent this kind of things, we in programming languages we use true or false. The type of which in technical terms is called as Boolean or bool for short. So that's at a high level, like how data comes in different formats and why we need to worry about it, right? So first type of data that we are talking about is strings. Strings are nothing but string of characters. Characters are like alphabets. So textual data is typically represented as characters, collection of characters, right? Sequence of characters. Enclosed in quotes, right? So that we can distinguish, yes, from the starting quote till the ending quote, it is text. Right? Let's say name is equal to, I cannot have like this, right? It gets confused. Okay. Till here I understand, but why there's a space in between? So what we do is that we put in quotes so that from this till there it is single. So this is a string. Okay. Now you see it accepted double quotes there. It is showing single quotes. So that's just a convenience which is given. Now I can use double quotes, single quotes, or even triple quotes in Python. Okay. This is also valid. Double quotes is also valid. Triple quotes is also valid. Triple single quotes. Triple double quotes is also valid. Okay. Sometimes Python pampers you too much, because of which it can get a little complicated. So people get confused why so many options are given. There are different purposes for this. Now, why these triple quotes are given is when you want to have multi-line statements. Let's say you want to, for some reason, you want to split the data across, split the value of the variable across multiple lines. In such cases, we use okay. So first part I entered in the top line, second part I entered in the bottom line. Since it detected that 3 triple quotes, till it encounters end triple quotes, it will not consider it as closed. Okay. So it has since between John and Doe, there's a new line character. It is represented. The new line is represented with this special character /n. So these are some things about the strings. Now, the strings are very, very, very important data types, because as network engineers, 90% of the time you will be doing something or other with strings, right? The commands that you will be, the configuration commands that you will be sending to devices, the output of the commands, some useful information that you need to extract from it, and you will normally get data in the form of CSV files, Excel files, JSON files, YAML files. You read the data into Python, you will get them as strings, then you'll have to process it, extract some information out of it, right? So you'll be doing so many things with the strings. So, and to be able to process these strings, we have some built-in functions on strings. Now, I created a variable called as name, which happens to be a string. Now, how do you know it is a string? Let's check type of name. Right. Typo in type. Right. Type of name is string. Now, dot system and the typo. Okay. So, as I said, like there are so many built-in functions or utilities which have been pre-created for you, right? So that you can you don't have to reinvent the wheel. You can just borrow the wheel and then get your work done. So, how do you know like what all are already available to you? We have a utility. Normally, what we used to do, we used to check telephone directory. Right? When we want to know, in the olden days, when we want to know information about like yellow pages or telephone directories. So same way, they created a built-in function called as dir, which stands for directory. Dir of string. Show me the directory for string. Right? It shows a lot of stuff which can be a little overwhelming, but you can ignore this double underscore stuff. These are all internal stuff. Right? Internally, it is used. What starts is the ones without the double underscore. Right? You see the things. I think it should already start making sense to you. Capitalize. Right? There's an inbuilt method called as capitalize, which means I have a string in lowercase. I capitalize it. I can capitalize it. There is something like count. I can count the number of characters in a string. There is something like ends with. I can check if a string ends with something. Like you have a like John Doe, whether it ends with Doe. Or same way, similar to ends with, we also have starts with. Right? Let's say you have a bunch of routers, some Cisco routers which are named with Cisco or CSCO or something, some keyword like that. Some Arista routers, Juniper devices, etc., etc. You can check, right, which device belongs to which group based on what that string starts with. So these are all called as methods, string methods, which are built in. We can use these methods on strings. Right? Let's say we have a device 1, which is like Cisco underscore router underscore. Now I can check device 1 dot starts with Cisco. What do you expect? Is it like asking a question? Does device 1 start with Cisco? Answer is yes or no. Right? So it is true or false. It says true. Does it start with? No. False. Right? Does it end with 01? Yes. Right? So this way you can use these methods like device 1 dot upper. It converts all the lowercase letters into uppercase letters. Right? Device 1 dot capitalize. Right? So it converted just the first letter into capital. Right? So these are some useful methods. I mean, you can explore now. So you got an idea, right? Like we have something like strip, L strip, R strip, and then strip. Like let's say I have my, like this, like I'm reading data from file. It is coming with a lot of white spaces, right? Both leading as well as trailing white spaces. Right? Normally for processing the data, these white spaces can sometimes wreak havoc. So let's say you want to get rid of these white spaces, and we can use these strip methods. Now, L strip, R strip are like, let's say I want to get rid of only these spaces. I don't care about these. So I can use L strip. So I'll say device 1 dot L strip. So the left side ones are stripped off and these are retained. So I'll do R strip. The right ones are stripped off, the left ones are retained. But why did this happen? Here we did L strip, so left ones should have gone. Here we did R strip, so everything should have gone, right? What happened here is, when I did device 1 dot L strip, it did not modify the original string, right? So another thing that you need to remember is, whenever you're calling these built-in functions on variables, there are some methods which modify the original data. There are some methods which will return new data by modifying the old data. Okay, so these are one such methods. For example, this upper, right? It just converts it into uppercase, but it does not modify the original one, because after calling device 1 dot upper, if I print device 1, again it will print the original data. Okay, so I did so many operations, right? Upper, capitalize, strip, etc. Let me print the original string. It is as it is. Okay, so none of these methods actually modify this thing. Which one modifies in strings? There is nothing that will actually modify the original one. Okay, so that's another thing that you need to keep in mind while exploring these methods. Strip will strip both leading and trailing. But then if it is doing something, but then it is not modifying, how is it useful? Right? How is it useful is we perform these operations. Now this is giving me the modified data. I'll store in a new variable. Or let's say I don't mind losing the old data. I'll store it back into the old variable itself. Okay, that's how you can use it. Okay, so that's what we have done here. These are some of the built-in methods that are there. Then the second important data type is lists. Right? Lists are useful, as the name suggests, list. Right? List is like a collection of items. So same way. Now, most of the times you'll be dealing with collections of items and not with individual items. Right? You're processing. You're building a HR software which has to process the data of all the employees. You're building a banking system which has to process the data of all the customers, their accounts. Same way, as a network engineer, you're dealing with multiple devices, right, which are of similar types. And most of the times the configurations that you'll be doing is same across the similar type of devices. So in such cases, these collection data types are very useful. Okay. So the collection, one of the very useful collection data type is list. How do you create list is, pick a name, list of devices or device list. What am I doing? I'm picking a name of a variable, which means a temporary storage location for storing some data. Right? Equality symbol says that yes, what I'm going to enter now, take the data and push it onto left side. Right? In school, you would have learned about this, right? Equations. So you take something on the left and the value on the right gets assigned to the thing on the left. Same is the principle here. Now list is denoted using square brackets. So whatever has to be put into the list has to be typed inside these square brackets. So we go inside, and list can contain, it's like list can contain any type of data. List can contain strings, integers, Boolean, or mixed. Right? In some of the programming languages, list of strings can contain list of strings, list of numbers. So the list has to contain all uniform data types. If it contains it should contain all strings only, all integers only. But in Python, that is not the case. So I can have a list like this. There's a string, then there's a number, then another string, right? And then I have another list inside a list. So in a sense, list can contain any type of data. There's a string, there's a number, there's again a string. This entire thing is another element. List inside a list. Right? Now I ask you to print my shows me as it is. No big deal. Right? Now this is an ordered collection of items, which means as we started entering the data, it kept count of, oh, okay, this is the first element, this is the second element, this is the third element, this is the fourth element, right? So it kept giving numbers to each element that we entered. That numbering, we call it as indexing. So lists are indexed. And this indexing is useful when we want to retrieve the data from this list, right? I've stored this data into this list variable. Now I want to get back the data. Let's say I want to get back only this. Okay? I'll say, give me the 0th element of this list. Why 0th? For some reason, most of the programming languages start their indexing from 0 and not 1. right? So list index starts with 0. So this is 0th element, this is first element, this is second element, this is third element. So that can be a little confusing in the initial stages, but you will get used to it. If you want the first item of a list, you should ask for 0th element. And the last element is, let's say 1, 2, 3, 4. 4 is there are total 4 elements. So the last element is at third position, right? That is 4 minus 1. Okay. Now, just like how we have seen the built-in methods of strings, we can check the built-in methods of lists using div. Now, this before that, let's check type of device underscore list. It shows that it is list. Right? You ignore this part for now. Its type is list. So now there are two ways I can check the directory. Either I can check div of list, or I can also say div of device underscore list. So either I can ask it to show me the data type, pass the data type and ask me to show the methods, or I can also ask me to show the methods which are available on this variable. This variable is of list, so it will output the same values. Luckily, they have, there are a lot of double underscore stuff. You can ignore all this double underscore stuff. These are little advanced stuff and will be used at a later point of time. So where the double underscore ends, that's where our interest starts. So you see, append, clear, copy, count, extend, index, insert, pop, remove, reverse, sort. Looks like it's making sense, right? Append something to the list. Clear the list. Copy the list. Count the number of items in the list. Extend one list with another list, right? Index, find the index of some element. Insert an element into the list. Pop an element from the list. Remove an element from the list. Reverse the list. Sort the list if it is not in sorted order. Okay, so these are built-in operations, and as I said, like the names are suggestive enough. You can try out. Again, the thing that you need to keep in mind is some of these methods modify the original list itself. For example, like I guess sort. Let's try it out. Device underscore list currently is this. So I'll call okay. Sorting, right? Cannot always be used because sorting. How do you sort elements, right? Sorting means it has to arrange in some order. Now, how will it arrange these mixed types in some order? So that's why it is complaining that if it has a list with all the strings, list with all the numbers, etc., it will sort them. But this is like a kind of heterogeneous list. It cannot be sorted. Let's try to reverse it. Right. So you see this reverse function has modified the original list. I just called this is my original list dot reverse. It modified the original list itself. It did not give me any output, but it has modified the original list itself. So when I asked it to print it again, it is showing me in the reverse order. So the last element became the first element, the next element became the second element, and so on. Okay. Now, how do yeah, we have already extracted list, right? Now, there is a, yeah, suppose you have another list. You see, this is a list inside a list. So how will I get that? Currently, it is at position 0. So I said device of 0. It gave me this list because this entire list was an element of this bigger list. Now, let's say from this, I want to go further inside and get this. I'll follow the same principle, right? Initially, this was my list. On this list, I applied this indexing. I got this. Now, this entire thing is my list. On top of this, again, I'll apply indexing. Right? So I'll take this. This is my entire, this smaller list now. Let's say I want 0th element. I'll put another notation. So finally, I get this. So this way, you can have any depth list, inside another list, inside another list. So you can break down bit by bit till you reach the primitive data, the actual data which is inside. Okay. Append and extend. Okay, I'll show you one important difference between these. Append is used to insert a new element into the list. For example, like this is my original list, right? Let's say I want to insert another item into this called as like loopback adapter. Device list dot, I'll say append and then pass. Append what I'm going to pass now to the original list. Okay, so if I ask you to print original list, so whatever I pass here got appended. Okay. So this was my original list. I'll recreate that without that part. Right? I'm creating a list again with just 3 elements. I create another list called as VLAN underscore list with this data. So I created 2 lists. One is a device list which contains some details about the device, and then VLAN list which contains VLANs. Now let's say I want to make this as part of the bigger list. So there are 2 options. One is append and extend. So I'll take device list dot extend this list with the other list. So what happened here? This list is broken. The elements are taken and inserted into the bigger list. Okay. Let's put it back, and this time we'll do append. What append has taken is it didn't break this list. It just took this entire list and made it as another element in the other list. Okay. So that's the difference between appending. Appending is as it is. It just takes that element. Doesn't matter even if it's a list. It just takes that list, adds it to the end of the bigger list. Extend, as the name suggests, extends the existing list. It breaks down the new list, takes the elements, and then makes them as elements of this outer list. Okay, I mean, if it's too much, to you, don't worry. With practice, you can get this. At least if you can, like appending, reversing, sorting lists, you can do this basic operation, or primarily being able to extract elements from this list using this index mechanism is the most important. How to put elements into a list, how to get elements out from a list. So that's the most important thing. Okay. And then there is another data type called as tuples, right, which looks pretty much similar to lists, except that tuples, we call tuples as immutable, which means once they are created, they cannot be changed, right? Like how I was playing around with the list, right? I extended the list, I appended the list, I took the original list, I added something to it. So these kind of things cannot be done with tuples. Other than that, lists and tuples are pretty much the same. But there should be slight differentiation in the way you create the list, in the way you create the tuples, right? Because that's a different data type altogether. So lists we use the square brackets to create lists. For creating tuples, we use braces or brackets. And put the same data. And it shows the curly braces. Now let's say I want to the way I extract elements is same, the way I do with the list. But in list, I can take the first element, like devise list of 1 is this. I can change this equal to 5. From 4, it has changed to 5. But I cannot do that for tuples. Tuple 1 is 4. I cannot change that to 5. It says tuple object does not support item assignment. That's what we said in the beginning, that tuple is immutable. Once it's created, it cannot be modified. Now, you might be wondering why this it is so. What is the big deal about it? Why it is created if it is cannot be done? Why it is done is internally, sometimes in the programming, right? Dealing with tuples is more efficient in terms of memory management compared to the list because of the additional restriction that is there on the tuples. So it makes it more efficient. So for all practical purposes, tuples are more advantageous at the system level. At the user level, we don't really worry about tuples. We don't even use them because lists are more flexible for us. We use lists. So unless there is a specific reason for us to use tuples, we will not be using. And another thing is, again, one of the best coding practices is when we are writing large programs, right? Sometimes accidentally we modify these variables. You have a list, accidentally you modify, you end up giving this kind of statement, which modifies your original list. So to prevent this accidental modification, we declare such things which should not be modified even accidentally as tuples. So these are internal stuff. You don't have to worry about it, except that just keep them in mind. Tuples are immutable. What do you mean by immutability? Once you create, you cannot change. Okay. Now you see this this device that I created. First element is something, edge router 01. Second element is something. Third element is something. Fourth element is something. But what do you guess these somethings? What could be the first element? The name of the router. What could be the second one? I don't know. It can be anything, right? It can be the number of things that you see here, or it can be the number of interfaces, or it can be the OS version. It can be anything. I don't know what it is. This, okay, I can still figure out. It is an IP address, but IP address of what? I don't know, right? These, yes, I know. Like, yeah, they look like VLAN names, but of what? They're already there configured on the device, or they're yet to be configured. I don't know, right? So while lists are useful to store collective tuple or list in production, there's nothing like production what you use. It's all programmer's choice. If the programmer feels that a list, the data which he is storing in that variable should not be accidentally modified, he goes for a tuple. Okay, so yeah, so while the list can store all the information about your device, unless, I mean, as a human being, I can make out looking at this, oh, this looks like this thing. But for the system, it doesn't matter, right? This is the first element, this is the second element. Even for us human beings, it is difficult, right? Now, as I said, like, okay, this I can make out, this I can make out, but what is this? And what is this? This IP address, but of what? What is its significance, right? I don't know. So we need to have another data type where you can establish some mapping, some association between a device's attributes and the values of those attributes. One such type is dictionary, where dictionary is a collection of key value pairs, where the keys are attributes of the which describe the device, values are the actual values, right? So for example, this is device name, this is number of interfaces, this is management IP address, these are VLANs which are configured on the device, right? So we'll define this such a way: device details, right? Now we exhausted square brackets, we exhausted parentheses, so we need a new type. So we use curly braces. Okay. So I'll pick a key. My first key is device underscore name. In this, I'll store this. Put a comma. Num intf FCs. In this, I'll put 5, comma, next value. Let's say this is GMP IP, management IP. In this, I'll put this. VLAN list, which are configured on this device. This I'll put this. So you see, we are defining, then I'll end my dictionary definition. Here I've opened the curly brace, here I'm closing, which completes my dictionary definition. So you see, this makes much more sense, right? Now, for every value, I have attached a description. What does that value stand for? So this is a better way to represent data. Like, let's say you have multiple devices which you want to represent. You will create multiple such dictionaries and put all those dictionaries in a list of dictionaries. Now let me print this out. It shows me the same format that I've entered. Let me check what is its type. Too many typos in the type. A short form for a dictionary is DICT, dict. Okay. So what's the thing that we need to do? We need to figure out what are the built-in methods. For this purpose, we use dir. So you say dir, either pass the variable name or you pass the type dict. So it shows here copy from keys, get items, keys, pop item, set default, update, values. Get looks like, yeah, I can use this to get the details from that. Items, right? I can find out what all items are stored in that. Pop some item from that. Then update the dictionary with new key or new dictionary. Values, right? Like I have keys, right? These are keys. Attributes are keys. So I have a method which can directly get me all the keys. When you have a method to get keys, you will also have a method to get values, which is this. Okay. So that way, their method will help you. Now you can go to another, you can take help from another useful function called as help. Right? In help, you can go to another level and ask, okay, help me with dict dot, let's say, values. Right? So what is the what does that values do? So it is saying d dot values. D is a dictionary, an object providing a view on these values. So like that, you can take help of this help function to get more granular help on each of these functions. Inside a dictionary, we added a list. Yes, we can add it. Can we replace the value with the element of the list device list by indexing it? Can we replace the value with the element of the, oops, I didn't understand the question. Can we replace the value with the element of the list device list by indexing it? Yes, we can do that. Is VLAN list inside a device list? Yes. Okay, so that is the, yeah, just a minute, give me a minute. Yeah, sorry guys. From morning I've been avoiding that call. Finally, I had to take it. Yeah. So where were we? Yeah. So that way, you take any data type, you use dir and help methods to get some additional help on the built-in methods which are available for dealing with that data type. Now, okay, we stored some data into a dictionary. How do we extract it? Same way as we extracted from lists and tuples, right? In case of lists and tuples, we used index, which happened to be a number. In case of dictionaries, also there is an index, but in this case, the index is nothing but the key, right? These keys. So the values in the dictionary are indexed using these keys. So while retrieving also, we'll use the elements. We'll use these keys to retrieve the elements. So we take the dictionary name, put the indexing notation. Instead of number, like we did in case of lists and tuples, we pass the key. We get the value. Okay. So there is no specific ordering, right? I cannot say like, yeah, get me 0th element, get me first element. Okay. Whichever key I ask for, that value will be returned. Now, in some cases, right, when we want to do bulk processing, we would like to get all these keys, then iterate through them and get the values using some techniques which we are going to see in a short while. Right, so that's where these methods help us. Right. So let's say I want to get all the keys. So I'll say dictionary name dot keys. Right. These are methods or utilities. So methods we always put curly braces. So we get all the keys in a somewhat list format. You see, this is a list format, but with the special type called as DICT keys. So this is not a normal list. So this is a kind of special list. Now the special list, I can always convert it into a normal list by wrapping it inside this list function. This is like type conversion, converting from one type to other. Now I get a list. I can take this list and here I'll have indexing 0th, 1st, 2nd, 3rd. Same way I can get values of the dictionary. Right? List of device underscore details dot values. I get values. So you see, this is like chaining. This is one function, one method. Inside this method, I'm calling another method. So, I mean, there's no restriction as such. You'll understand when you gain a little more experience with Python. Okay. I take this and this entire thing, I convert it into list. So that's how you extract values. Now, if you say items, you get both keys and values as a tuple. So you see this tuple. List of tuples. This is first key, first value, second key, second value, third key, third value, fourth key, fourth value. You get as tuples. All these tuples are put inside a list. So you get a list of tuples. Okay, that's about dictionaries. Making sense? We are slowly building our toolkit, right? We started with the data, then how the data gets stored in variables and what all different types these variables come in, and then how we can handle different types of complex types like strings, why we need lists, what are tuples, what are dictionaries. Okay, so that is like kind of basics, right? Till now we have not thought about like how do we build a program, which means program is there should be some logic, right? We'll be writing a program to solve some problem. So the solution to that problem will involve applying some logic. So from now we'll start applying that logic, right? So the first one's the programming construct. We call it as conditional statements, right? This construct, programming construct, conditional statements will help us to evaluate certain conditions and take decisions. Right? During the program execution, we'll come across certain conditions like what is the name of the device, right? What type of device is it? How many interfaces it has? How many VLANs it has, etc., etc. Like these are all like, let's say, different conditions. Based on these conditions, we want to take some action. So that's where these conditional statements come into picture. So how we evaluate this condition is using a keyword called as if. If a condition is true, then take this action. If that condition is not true, take some other action. So that's how we apply this conditional logic in our programs, right? Let's say it's like saying if the device type is Cisco, send Cisco style commands. If the device type is something else, send that OS specific commands. Right? Let's say you have written a program to send commands, config commands using some of the tools that we are going to see. So there you are dealing with multiple devices. They come in a list or a dictionary. So you take each device and then you need to find out what type of device is it. So that's where you have some way to figure out which happens to be a condition. Like one condition could be the name, right? Name starting with Cisco. So if device name starts with Cisco, then you know that, yes, it's a Cisco device. Then what is the action that you want to take? Send Cisco style commands. If not, we call it as else, right? If else. If device type is Cisco, do something, send Cisco style commands. Else, send generic commands. Now it cannot be like that, right? I can have like multiple types of devices, like device type Cisco, device type Arista, device type Juniper. So to handle such cases, right, it's not like black and white. There's a gray also in between. So to handle such cases, we have something like if, else if, multiple else ifs. And at the end, you can have else, right? If device type is Cisco, send Cisco style commands. Else, if device type is Juniper, send Juniper style commands. Else, if device type Arista, send Arista style commands. Else, which means it doesn't fall into any of the above conditions. Then you don't know what to do. So you print a message saying, I don't know what type of device it is. Okay. So that is how these conditional statements will will help us in taking decisions, right? So if you have a condition or a text expression, you evaluate it. This conditions always result in true or false because the kind of question we ask is like that. It returns in true or false. If this condition is true, do something else, do something else. Okay. The example that we see is like, yeah, we have a dictionary, facts dictionary. We take this. Vendor, management IP, chipset, host name, OS version. Right? Right? Let's say I'm building a list of all Arista devices. So I'll create an array. Arista underscore devices is equal to list. Right? There's a blank list. So this is how I can create a blank list. Currently it is blank. Now I get some multiple such dictionaries where with the different vendors. So I need to check each dictionary, what type of, who is its vendor. Accordingly, I need to push it into that device. Right? I have Arista devices. I have another list, Cisco devices. Right? So when I get such data from, let's say, Excel sheet or somewhere, first I will have to check what type of, who is its vendor. Accordingly, I'll decide whether to push it into this or into this. Right? That's what I want to achieve. So what I'll do is, if facts of vendor, right? First, I need to extract the vendor information from this. This facts, I mean, I'm just calling this facts as this is the name of the variable I've given to this data, right? There's nothing fancy about it. Facts of vendor is what will you get? You'll get Arista. If facts of vendor, this is the way we compare, right? In comparison operators, we saw how do we compare two values? Is Arista. Right? We put a colon saying that yes, I've finished my if part. What follows is the statements that I need to take care. If facts.vendor is Arista, what do I need to do? I need to push this device, facts device, into Arista devices using list append method. What I'll do, I'll say Arista devices dot append facts. Okay, the name facts could be a little misleading. Probably I should have called it as device because it describes the device details, or I called it as facts because these are like facts about the device. Right? So I'm adding this device to Arista devices list. Else, if, right? Suppose this is not the case. Else if facts of vendor is equal to Cisco. Made some mistake. Sorry, it's not else if, it's elif, shortened form. Yeah, now I messed up. If this, then this. Elif, if it is of type Cisco, then push the device into this list. Dot append facts. Now our condition is executed. Let's check which of the lists it has gone into by printing both of them. Arista device is populated. Cisco devices is blank because vendor is Arista. Okay, so that is how we have used if, else if. I could have added else, right? Else, which means vendor is neither Arista nor Cisco, like something else. Then we can print something like, I don't deal with these kind of devices, right? I only deal with Arista or Cisco. Something like that. Why it is now in curly? Because this is, I've taken this entire dictionary. This is dictionary. I've taken the entire dictionary and pushed it into a list. So outside you see the list notation. Inside you see the curly brace because this entire dictionary now went and sat inside a list. Okay. Now this list, this outer brackets, curly braces, right, makes it as a list. This list has only one element, which is this entire stuff. Okay, so that is your conditional statements. It depends on your use case, right? I mean, in this case, I've chosen it to implement it that way. That the entire dictionary represents one device. So I'm checking who is its vendor and then making this entire dictionary as an element of a list. Let's say I just want to make a list of host names, right? So I could have simply, instead of pushing this entire device into this list, I'll simply extract the host name, which happens to be a string, and then push it into the device so that this device list will contain only the host names and not the entire device. Let's say now I'm defining another device called with the vendor as Cisco. If facts.vendor is Vista, then Arista devices append facts. If facts.vendor is Cisco, then Cisco devices.append facts. Else print unknown vendor. Okay. Now Cisco devices would have got populated with the second device of type Cisco. Now you're seeing this problem, right? Every time I'm having this new device, I'm having to type all these commands again. So this is the right time. So far, we have been working on the interpreter on the CLI. So this is the right time because we started writing complex statements, which are where this indentation is very important, and it's becoming a little cumbersome for us to work on the CLI. So this is the right time we make a switch to editors, right? Popular choice being Visual Studio Code, VS Code. Right? This VS Code can also connect to remote systems. Which system I'm currently using? It is my WSL, Windows subsystem for Linux. Can connect to WSL. Yeah, forget it. Let's connect to. Okay, Visual Studio Code is a very powerful code editor. It's not just code editor. Because of this such powerful facilities, we call it as an IDE, integrated development environment, which means without leaving the IDE, you can write code, you can test it, you will have so many other utilities. So one such utility is a remote connection, right? I can connect to remote host straight from your code editor. Like normally, let's say our code is lying on Linux system, we want to work on Windows system, we use WinSCP or FileZilla to connect to Linux system and then get the thing here. Right? Instead of doing all that, straight away from your code editor, you establish connection to your Linux machine. Right? Now, when I say open folder, it is showing me my Linux folders. So I'll open my work folder, see my previous work. I know today is taking a lot of time. Normally it should not. So I'll create a new folder to store my Python work. Inside this, I create a new file, if test.py. It says there's a Python extension. I don't have Python extension already. That's strange. Okay, this is for remote. Right, the remote environment is completely maintained separately. Yeah, so that's another cool thing about this, right? It detects what kind of code you're working on, and accordingly it keeps suggesting, okay, I have a useful utility for you. So this play button has come in. So detected that it's a Python file. I can execute by clicking this run Python file. what I wanted to do. Yeah. Okay. I'm defining my data. Then if checking some date, some condition on that data, and then taking some decision. This is saying this because I don't have the devices. Devices equal to blank list. Okay. So define your device, define the blank list. If some condition is evaluated, then push it into this. So I can click here. It opens my terminal, and then it has executed the code. The thing happened. So we can check it using by printing. Now I'm writing code, so I'll have to explicitly print devices. No such file or directory. Okay, it's not able to find Python. Python 3. I'll change to ls cd Python 3 file name. Okay, this time I'm taking only the host name and pushing it into the list. I mean, it's already installed. Somehow this this option, right, display option, is not able to find the right Python binaries. So instead, I know how to invoke this using directory Python 3. So I can execute from here itself. Okay, so shall we continue or enough? Okay. Okay. So we have covered quite a bit, yeah, on different data types, and then if statements. You cannot see play button, but for that you will have to install those plugin. And search for Python plugin. Click here in extensions. Search for Python. We'll see it like this. Then click the one from Microsoft and then install. Any more questions? Okay, thank you everyone. Good night.